Good morning and welcome to today's Amazon Web Services webinar. My name's Ian. I'm a technical evangelist with Amazon Web Services here in Europe. And this is the first of our Masterclass webinars for 2014. So this is a series of webinars that are intended to provide a technical deep dive. This particular webinar is going to be focused on Amazon S3, the AWS Simple Storage Service. And the focus of this webinar is going beyond simple use cases, so we hope to show you today how you can get more value out of the service. The slides that I'm going to present to you today will be available immediately after this webinar ends, so please don't waste time making notes. We're going to make all of the materials available to you straight after the session today. There'll also be some links within the slides, including a link to a GitHub repo that will contain the code samples that I'm going to be talking about today. So the materials will be provided to you. If you've got questions about the content, please submit those in the chat question and answer facility within the webinar platform. It's unlikely that we'll be able to answer them during the webinar today because we've got quite a lot of content. But if you submit a question, I or another member of the AWS team here in Europe will get back to you with a response very, very quickly. So please do raise any questions that you've got and we'll provide feedback on those after the session. Okay, let's get started. So, as I've already mentioned, these Masterclass webinars, they're intended as a technical deep dive which should take you beyond the basic understanding of the service that we're focusing on. We're trying to educate you here about how to get the best from AWS technologies and services, show you how things work and how you can get things done in a more efficient or effective manner. And the webinar will last about 45 minutes, but it's intended to broaden your knowledge, so I really hope that we can help you achieve that objective today. As I've said already, today we're looking at Amazon S3. Now it's called the Simple Storage Service, but there's actually a lot more to S3 than that simple storage platform. It's actually a very sophisticated and modern distributed system, and many AWS customers use S3 as a bedrock architectural component for the applications that they are running on the AWS platform. So we're going to start first of all today just by talking about a couple of example customers that are using S3 so you can get a feel for how customers are using the service and how they're using some of the advanced features as well. So first customer that we're just going to quickly talk about is Spotify. It's quite a well-known user of AWS, but many people don't appreciate that Spotify actually use S3 as the foundation for their internet music service. So all of the content that's available on Spotify, and you'll know that's millions and millions of songs, is stored in its master version within S3. So a very, very scalable example of a customer using the service. And they selected S3 principally for its maturity, the fact that it's a very, very robust product with very, very high durability, and we'll talk about what durability means in a few minutes and how we achieve that. But also because of the scalability characteristics, the elastic nature of the service. And you can find out more about this case study when you get the slides if you just follow the link that's at the bottom of the slide there. But Spotify are a great example of an organization that are using S3 to power a high-scale internet business. Another super example, which I really like, is Mojang. So these are the guys that develop Minecraft. I'm sure you'll either have heard of this, or if you've got a kid living in your house like I do, a 10-year-old, it seems to be the primary thing that my stepson does in the evening is to go into Minecraft and work on construction projects with his friends. So it's a great product, and it's been a runaway success. There's over 14 million people that have bought the PC or Mac version of Minecraft. Now, you'll know that it's a multiplayer game, but traditionally you've had to be pretty technology savvy in order to run the multiplayer environment for Minecraft. Well, Mojang just announced quite recently that they're going to operate these realms, which will be a managed version of the multiplayer environment for Minecraft, which you'll be able to access by paying a monthly subscription fee. So very, very simple way for people to collaborate and have their own private game world. And that service is also going to be backed by Amazon S3. So this is going to take advantage of a few advanced features, actually. They're going to be using versioning, which will provide owners or realm administrators the ability to roll back to a previous game state, which is a pretty powerful feature. And they've also boosted the efficiency of data transfer into S3 by using something called the multi-part upload capability. So using a couple of advanced features to deliver a very, very high scale gaming service there. And once again, you can find out a lot more about that case study and how Mojang are using S3 by following the link that you'll find at the bottom of that slide when you download the material. So there's a great couple of customers that are using S3 in order to power their businesses. Just talk about some of the basic characteristics of the service. Now, the most basic characteristics of S3 really are that it's a web service, so you place and retrieve objects into S3 using a web services API. And the second important characteristic, foundational characteristic, is that it has extremely high durability. There's 11 nines of durability there, which is incredibly high, and that means that you can have a really high degree of certainty that once you've placed an object or a piece of data into S3, you'll definitely be able to retrieve it when you need it. So those are the basic components, but as I've said at the top of the webinar, there's more to this than just a simple storage service. One of the characteristics that you need to be aware of is the extreme scalability that the S3 service can offer. There are trillions and trillions of objects stored within S3. It's a global platform, and it's available in each one of the AWS regions around the world. So there's 9 of those today, with a 10th one coming online soon in Beijing, China. And not only does it store this massive number of objects, but it also deals with huge amounts of request concurrency. So at the moment, in the peak period of the day, in the peak period of the week, AWS S3 is servicing over 2 million requests per second. So a hugely scalable service with characteristics and capability to support very large workloads, storing huge numbers of objects and dealing with very high request concurrency. Just digging into a few of those characteristics in a little bit more detail. We touched upon some of this already, but what we're talking about here, as I've already said, is a web store, not a file system. And there are some characteristics of the web store that are distinct from the file system that it's worth just exploring very quickly. And one good way to explore those characteristics is just to talk about the conceptual architecture that's used to deliver S3. So we'll just move on to do that now. The service is built within an AWS region, so each AWS region has an S3 service available in it, and the S3 service takes advantage of the availability zone architecture that exists within each region. So what would normally happen when you come to place a piece of content into the service is that your API request is going to hit one of the load balancers within that availability zone, and then it will be directed onto a web server which maintains the API service or runs the API service. You obviously insert your piece of content, your object, through the API, and once you've done that, that object will be written into multiple storage containers within that availability zone. It will be replicated to storage infrastructure in a second availability zone, and once that's been done, state information will be written into a local index in the first availability zone, and that state information will then be replicated into the secondary set of indexes in the second availability zone. So that you can see from that architectural model and that data flow diagram how we go about distributing copies of the data and copies of the index across those two availability zones. And remember that each of those availability zones is a completely separate failure domain. So once the data has been written into those multiple locations in storage and that has been recorded in those multiple indexes, you're left with a very durable store which can provide failure tolerance. So if, for example, there's any issues with components in the primary availability zone, there's obviously redundancy there, as you can see. So even if we're losing load balancers and web servers and parts of the storage and indexing infrastructure in that availability zone, there's lots of resilience built into the architecture to ensure that that doesn't mean that your data is not accessible. And even in an extreme situation where a complete availability zone is lost for some reason, we've got a completely secondary set of indexers and secondary set of storage nodes which will ensure that you've got still got durability of the data and still got accessibility to objects that have been stored within the S3 platform. So it's built with the highest possible levels of redundancy to ensure that we achieve that 11.9's durability goal. Now, the way that it's architected, of course, leads to this eventually consistent characteristic. And what that eventually consistent characteristic means is that it may take a little bit of time for objects to become available once they've been written into the API, and also if an object is updated or deleted and then you very, very quickly attempt to do an object read, you might find that you get back either the old object, or in the case of a delete, you get back an object that's just been deleted. And that's a characteristic of something called the CAP theorem, which deals with consistency and availability and partition tolerance in distributed systems. So the eventual consistency, if you like, is a byproduct of the very high levels of durability that we're seeking to achieve here. And you just need to be aware of that in your application design, that it's possible that you could receive a copy of an object which is slightly out of date, or receive an object even though you've just deleted it. If you wait a few seconds and try again, consistency will be achieved, and then obviously that object will be the new object, or if that object's been deleted, it will have disappeared from the system. So just bear that in mind. It's a side effect, if you like, of the durability characteristic. Right, this is really important. So as I've already said, there's an S3 service endpoint and an instance of the S3 service available in each of the AWS regions around the world. And your data will not leave that region unless you move it. So you can consider each of these endpoints and each of these AWS S3 service locations as separate instances of the service. You need to write information into a specific region in order for it to be available there, and your data will not leave that region unless you take action to move it to another region. So this can be important for organizations that need to have their objects and data stored in specific locations for regulatory reasons or for compliance reasons. For example, if you know your information can't leave Europe, store that in the EU West 1 region, and that information will be stored in Ireland, and it won't be moved out of Ireland unless you take action and write another copy of that data into another one of the S3 locations around the world. So it's quite important to bear in mind for regulatory and compliance reasons. Okay, we're going to move on now and talk about a few more detailed features of the service. So the first thing we're going to talk about is storage classes. This is about controlling the way in which S3 holds your data. There are 3 storage classes. The first is the standard class. This provides that very, very high durability characteristic that we've talked about, and it provides for 99.99% object availability over the course of a year. It's designed to sustain concurrent loss of data in 2 facilities. So this takes advantage of all of the availability features that I talked about earlier in the webinar. The second storage class is something called Reduced Redundancy Storage, or RRS. This is intended to enable you to lower the costs of storing data, and it achieves that by tolerating, allowing for a lower level of durability. So once again, it's for 99.99% availability, but also 99.99% durability. And we'll talk in a few minutes about some application use cases which might make that a more appropriate option for you to use. And then lastly, we have a third storage class, which is called Glacier. This is the newest of the 3 storage classes. This is suitable for archiving data, where your access to that data is infrequent, and you've got it's acceptable if you retrieve data in several hours. So it's intended for what you would typically call deep archive use cases, where you don't mind if you have to wait several hours to get your information back. The upside, of course, is that it's an extremely low-cost service. So at the moment, the pricing is $0.01 per gigabyte per month for data that's stored in Glacier, or in that order of magnitude. So it's extremely low cost, and it's suitable for very, very low-cost use cases. Now, how might you use those 3 different classes? So let's just take an example of a customer that's working in the media space and dealing with digital media. Well, you may store your master media copies on the standard in the standard storage class, where you want that very, very high durability. You want absolute certainty that you're not going to lose the master copy of the movie media that you're storing. You may use RRS if you're creating data from that master source and you're able to recreate it. So in this media example, that would mean, for example, different encodings of movie media which are at different bit rates. Well, store those in RRS. It'll reduce the costs of storing all of the different bit rates that you need to store, different versions of that file. And if you lose them out of RRS, you can recreate them with a recreation process. And then in Glacier, you could use that for long-term archive of old movies and broadcasts that might just be required in very unusual circumstances, or might not be required in real time, but you want to try and minimize the cost there. So those are just some quick examples of how you might use the different storage classes. Later on, we'll talk about mechanisms for moving data between those storage classes automatically, because that's also a feature of S3, a very powerful feature actually. Right, let's move on now and talk about namespace. So I'll give you a little bit of detail on how object naming, how buckets and keys work. So the Amazon S3 namespace is globally unique, so you cannot have two objects or two combinations of object name plus bucket name globally that are the same. So the way that we enforce that is by enforcing global uniqueness on the bucket names. So when you come to create a bucket in S3, which is the container that you store objects in, you cannot reuse a bucket name that's previously been reused by another Amazon S3 customer. So that's a constraint, obviously. And the way that many organizations get around that, as you'll see in a second from an example, is to use domain names in their bucket names, because domain names, of course, are also globally unique. So if you prefix your bucket name with your domain name, you dramatically reduce your opportunity to have a namespace clash and therefore get a warning when you try to create a bucket. So that's a good bit of best practice to bear in mind. The bucket and object construct is a mechanism for organizing the objects that you're storing. So just to put a little bit more color onto this slide, you can see here 3 examples of bucket names, a couple of which use the domain name construct, which I just mentioned there has been best practice, and one which uses a more conventional name and suffix bucket name. And you can see that there are a couple of objects stored in each of those buckets. Okay, the object keys, they need to be unique within the bucket, but you can use the same object key in different buckets. That's fine, and that's perfectly permitted. Okay. And object keys themselves, well, they're 1,024 byte long UTF-8 encoded strings, okay, and they include path prefixes. And the reason that path is in quotes there is because they're not really paths. It's not a folder hierarchy in the sense that you would have a folder or directory hierarchy on a file system. The prefixes are just part of the key name. So the slashes are part of the string, and the folder or hierarchy names are also part of the key name. So it's a mechanism for achieving partitioning, and it's also obviously a convenient naming convention that most developers and users are familiar with to organize objects into that kind of hierarchy. Let's move on now and talk about throughput optimization. So S3 automatically partitions based on key prefix. What this means is that data will be distributed across different index and storage nodes on the basis of the keys that are used. So this can lead to some unintended consequences, but it's possible to avoid those. So in this example, we've got an incrementing game ID, which is the first part of the object prefix, and you'll see that all of those game IDs start with the same prefix, because the developer that's created this bucket and is storing this data is using sequential numbering for the game IDs and then creating some objects underneath those game IDs in the key structure. Actually not a great idea to do this if your data, your objects have got high access concurrency. In other words, a lot of people are accessing objects simultaneously. That's because all of those objects would likely end up in the same partition, because the prefixes are very similar. So a mechanism that you can use for optimization here in this particular example would be to reverse the game IDs, and you'll see that the prefix now has a little bit more variability in it, and by doing that the objects would automatically be distributed across 3 different partitions, and therefore you get substantially higher throughput when accessing those objects. So that's something to bear in mind. It's not a good idea to cluster all of your object keys with the same prefix. So try to avoid using dates or sequential object keys in the native format. It's a good idea to either hash them or reverse them in order to improve that optimization. Okay. Move on now and talk a little bit about encryption. Obviously, it's key for certain use cases that data can be secured while it's at rest. And we have something called server-side encryption, which can address this requirement. So it's very simple to use. Okay, you just put an additional put header in the request to S3, and that will result in your data being encrypted while it's being stored using a strong AES-256 block cipher. Okay, it's very durable because the keys themselves are also stored within S3. and this enables you to achieve automatic encryption of data while it's at rest. And obviously S3 will deal with your key management, so you don't need to self-manage a key store on your side. The way it works basically is you put your data into a bucket with the appropriate put header to specify that you want that piece of data to be encrypted while it's at rest. That will result in your data being encrypted with a per object key. The per object key will also be stored in another bucket on S3, and then, oh, sorry, that's not correct. The per object key will be encrypted with a master key, and then it will be stored in another bucket on S3. And those master keys, they're rotated on a monthly basis. So that provides you with a strong mechanism for encrypting data while it's at rest within S3 in one of the Amazon regions around the world, the AWS regions around the world. And it can help you meet certain compliance requirements that you might be required to meet. It's extremely simple to activate. So if you've got a bucket where you want to turn on server-side encryption, just go into your console and click Use Server-Side Encryption there, and that will encrypt the objects that you upload in that upload session. And obviously you can access that and drive that via the API and via the various SDKs that are written using the the AWS API also. There's further details on how server-side encryption works and how you can access it with the API and also with the SDKs. If you follow that link at the bottom of the slide down, obviously download the slides after the session to get that. Okay, let's move on to another aspect of security, which is access controls. So you're putting information, objects, data into S3. How do you secure those objects, that data, to make sure that it can only be accessed by authorized individuals? So the first important thing to note is that by default S3 is secured, so only the user account that creates a bucket can access information that's been stored within that bucket unless you take action to reduce the level of access control that applies to the objects that you're storing. So you decide what to share, you apply policies to objects and buckets in order to open up that access, okay? Those policies take three forms: S3 policies, ACLs, or you can use AWS Identity and Access Management, IAM, to define those rules. We'll just have a look at the differences between those three options. So taking the last one first, which was IAM, this is very fine-grained control. It allows you to integrate the permissions that you apply to S3 objects or buckets as part of an overall role-based access policy that you define within the IAM tool for your AWS account. It's very, very fine-grained, and you can apply policies to S3 at the role, user, and group level. So this means that you can restrict specific actions that a user can take. You can restrict specific users, and you can also restrict groups. And you'll see there an example of an IAM policy that allows only the put object. So with this policy, those users would only be able to upload objects into that specified S3 bucket, and they would have no other access. Okay. Second mechanism is to use bucket policies. These are fine-grained, but rather than applying them within IAM, you apply them within the S3 console, on the AWS console, obviously, so the S3 subsection of the console. It allows you to incorporate user restrictions without using IAM. So if you've got a simple account structure with single users, and you want to allow public access to buckets or public access to specific prefixes within your bucket, this is a good way to achieve that without having to sort of get engaged in full-blown IAM configuration. And then lastly, you can have coarse-grained ACLs, which are much more simplistic and allow you to apply coarse-grained access control rules either at the bucket or object level within S3. So a bit more simplistic and controlled via the console user interface rather than via pasting in textual bucket policies, which you have to create in a text editor or type into a field in the console. So a little bit more simple. Let's just have a look at an example of a bucket policy just so you can see how they're constructed. Just like an IAM policy, these are JSON notation files, text files, which you can either create in a text editor and paste in to the console, or you can edit directly in the console. This particular policy, well, what this policy does is it says that you're going to allow these two AWS accounts access to a resource which is called MyBucket, and actually the star at the end there indicates that they can access all objects within MyBucket, but that access is restricted to requests that come from this specific IP address range. So this might be a mechanism for allowing only users that are on your corporate network to upload, modify, delete, and download resources from that specific bucket. So very, very powerful, and obviously you can have very, very complex and descriptive statements within the policies that allow you to get very, very fine-grained control over the resources that you're creating within S3. So take a look at the documentation for that on the website if you want to know more. There's a lot more to cover on that. Okay, let's talk about traditional lifecycle management. So when we were talking about storage classes earlier in the webinar, I mentioned that it was possible to automate the movement of data of objects between storage classes, and transitions and lifecycle management are how you achieve that automated management of objects. Lifecycle management has a couple of different characteristics. The first is object deletion. So you can set lifecycle management policies that will permanently and automatically delete objects from S3 on the basis of time. So how long, for example, since an object was created do you want it to persist for, and at the end of that lifetime you can have that object automatically be deleted. Secondly, you can have object archiving lifecycle management policies, which basically allow you to move objects between storage classes, as I already mentioned. So this is a mechanism that you might use to automatically move objects to Glacier and out of S3 storage after a certain time period, so reduce the costs of your long-term archive without having to take any action. Now, for those of you that have previously administered traditional storage systems, these could be regarded as advanced features, but when you're dealing with the kind of scale of objects and the scale of data that many customers that are using AWS 3 are, these are really essential tools to reduce the cost of managing your information, managing your objects once you've created them. So we find that many customers use these features, even though you might consider them advanced features if you used to traditional storage products, storage infrastructure. So Glacier is obviously a key component of this, the long-term durable archive, and as we've already said, it's a highly durable service which mirrors the durability of S3 itself, but it's more cost-effective, being designed for write once and read never applications. So it's very cost-effective for long-term storage, but you do pay a small charge when you access data that's been stored in Glacier. So it's not intended for applications where you need frequent access to data. If you need that, keep it on S3 or use RRS. Let's have a look at a sample expiry use case in this lifecycle management model. So we've got two different classes of data that we're going to be dealing with here. The first is log data. We're going to set a policy for log data, which means that it's stored for a period, but after that period has passed, those objects will expire and be automatically deleted from S3 without you having to take any action. Got another kind of data, which is transaction data. This data we want to record and retain in this particular example for regulatory purposes in case the regulator comes along and says, right, we need to see a transaction that happened 4 years ago. We're going to store those transaction logs in Glacier. If we get a regulatory data request, we'll grab that information back from Glacier and we'll be able to get it. So with this lifecycle policy, we can transition those transactions over to Glacier automatically without having to take any action. And if we need that information back, we can make a restoration request. The object will be returned back to RRS after a period of about 3 to 5 hours, which is how long it takes to restore data from Glacier. And that information will be held in S3 RRS for a predetermined time period. And at the end of that time period, it'll be deleted and the copy will be retained back on Glacier again. So the important thing to note there is that 3 to 5 hour retrieval time. So we're assuming that information that's stored in Glacier is not required that frequently. You do this by setting these lifecycle rules, and this shows you how to set lifecycle rules in the S3 console. And you can see here we're creating a lifecycle rule called 10-year archive policy. We're applying that to the entire bucket rather than just to a single prefix, and we're using days from the creation date of the object as the trigger for that lifecycle rule. And you can see at the bottom we're going to move objects to Glacier after a year, after 365 days, and we're going to expire and delete those objects after 10 years, after 3,650 days. So setting up these information data lifecycle rules is that simple. You just put that information into the console and that's it. Very, very simple. You can also, of course, create these using one of the SDKs if you want, and you can see a code sample here, a .NET code sample, which shows the creation of lifecycle rules using .NET. In fact, the same lifecycle rules. So this block here is used to create the transition where we're instructing S3 to move objects down into Glacier after a year has passed. And the second code block here is used to create the expiration rule where we're going to expire objects from S3 and Glacier after 10 years have passed, and those objects will then be deleted. So super simple mechanism for creating lifecycle management rules. And then when you want to restore data, well, you can do that via the console. So this shows how you would initiate a restore on an object from within the AWS console. So this is looking at an object that's been stored within Glacier. You right-click on the object, you select Initiate Restore, put the length of time that you want the object to be available in RRS for once it's been restored. Click OK, and Glacier will go away and start work in the background and recover that object for you in a 3 to 5 hour time period. So that's pretty simple. You can also do those restore requests via the API. So this shows a XML request via the REST API to do a similar sort of activity. The orange areas, orange sections here are things that should be replaced with the appropriate data. So you need to insert the object name, bucket name, the date, obviously your API signature, and you're pushing the number of days that you want to restore the object up through the API in that bit of XML at the bottom there, and that's how you would initiate that restore request via the API. And here you can see the response codes that you'll get back. So when you initially do that, you'll get that 202 code saying your restore request has been accepted. Once the object's been restored, you'll get that 200 code. And if you repeat the request with another number of days, you can actually update the period for which that object will be retained within RRS. So if you decide you want to keep that object a little bit longer, repeat the API request with a new day value, and that object will be retained in RRS for that updated period of time. And then lastly, if your restore is already in progress and you issue the API call, you'll get that 409 conflict restoration already in progress. So that's how you can enable your applications to monitor the status of restore requests that are already in progress. Okay, so that's everything on life cycles. This next section's interesting. This is what I think many people at AWS might consider a sort of underutilized feature of S3, and we've got a lot of people within AWS that are using this service, and also a lot of customers that discover it, and when they discover it, they think, wow, that's really great. So because S3 is a web service, you can use it directly to serve up web content. Static web content can be served directly from S3. So you've got a very, very low cost mechanism for storing content. And as we've said, it's an extremely scalable service as far as object concurrency is concerned. So if you've got a site which is static and you don't know how much traffic you're going to get on that site, could well be more cost effective to put it in S3, the static components in S3, than it is to host it on EC2. So just bear that in mind. So how do you do it? Well, the first thing you do is in the console, you need to find the bucket that you want to use for static content hosting and go to the Enable Website Hosting section of the properties. If you tick that radio button, you'll be asked to enter an index and error document. So that's where you set the default documents that you want to be served. And obviously, you need to have objects in your bucket that correspond to those document names. So create an object called index.html, which contains the HTML for your index page. And if you want to look polished, obviously create one for the error page as well, in case somebody requests an object which doesn't exist. You don't want to get them seeing an ugly XML error message, create that error page, and you won't have that. You can also, and we'll come to explain why this is useful in a second, you can also set up redirection requests directly within an S3 bucket. And you can see here there's an example URL that's been used there to redirect requests to another URL, and obviously you can use that as a mechanism for cleaning up requests that might come into subdomains or hosts within your domain, so that all your traffic ends up in a master S3 bucket where you have your static content updates taking place. Now, when you do that, you also need to set a bucket policy to enable public access to the objects within that specific bucket. And you can see here an example of a bucket policy that enables that public access, allowing anybody, with the principle here is star, which means anybody, to perform the get object action in the S3 scope, and that is basically enabling anybody to perform a HTTP GET on any object that's stored within this example bucket that you can see at the bottom here. And this code sample is going to be made available in the GitHub repo that accompanies this webinar. So if you want to grab that and use it, you can do so. When you turn on static website hosting within S3, you'll be given a different address to use for your S3 bucket, and you can see an example of one of those addresses here. So this is the address that you should point your CNAMEs at if you want to use multiple addresses to access your bucket, rather than the normal addressing that you can see at the bottom here. Let's just show you now how to do URL redirection. So we're going to take an example here, which is the AWS-exam.es domain. To set up website hosting for this particular domain, we'd create a record set for that domain within AWS Route 53, our DNS service. And in this particular case, we want to store our content in a master bucket, which doesn't have a www prefix in front of it, but we want to redirect users that might use the www prefix to that master bucket where we're going to do our content updates and keep the objects that constitute our static website. So we need a website redirect, which will direct traffic that hits the www prefix over to the master bucket that we want to use there. So how do we go about setting that up? Well, the first thing to do is to set up the master alias. Now, if you go into Route 53 and look at the record set for the domain, you'll see there's a special record type that you can create there called an A record alias to an S3 website. And if you select that record type, you'll be presented with a drop-down which shows the S3 buckets within your AWS account that have been configured for static website hosting, which makes it super simple to set up a record which points to one of those buckets. So for this example, we would go into the Route 53 console, choose the record set for the AWS-example.es domain, and we would create one of those A record aliases which points to the S3 website that we've already set up. We're then going to go in to the same record set, and we're going to create a CNAME for www.example.es, which points to the bucket which has the redirect on it. Now, the effect of doing that will be that anybody that goes to the bucket with the www prefix immediately gets redirected over to the master bucket, and they get a very, very clean experience, and most importantly, we only have to keep our static website content up to date in one location. Now, you can find more details about this if you visit the URL, which has been on the bottom of these 3 slides, which explains a walkthrough of this custom domain hosting. But that's what you'll see. You'll see the requests to the www address get redirected onto the naked domain, the clear domain, and you've only got to update your content in one place, and you get that high scalability, and obviously it's very, very simple to set up as well. So really cool service for static websites. And of course you can use that with static content generation tools like Octopress and others to push pretty complex websites into an AWS bucket via the API, and serve all of those up in a very simple and very, very cost-efficient manner as well. Okay, so now let's move on and look at time-limited URLs. It's a pretty cool feature. This is used by quite a lot of customers that are in the media space that are using S3 to store media objects that they only want to make available for a certain period of time under certain access conditions, and then they want to expire them. So what you do when you do this is you get these signed URLs, and you can see an example of a signed URL here on the screen. The signed URLs, they provide time-limited objects to specific objects that expire after a set period. You can use them on objects that are in buckets that don't have a public access policy. The signed URL will work, but once the signature has expired, the non-public access policy will prevent access to that object. So it's a cool way for you to give out URLs that only work for a set period of time. There's a code sample here which uses Python, the Boto Python SDK for AWS. You can see here we're creating a connection object to S3 using the boto.connect object method. And then we're calling this generate_URL method with a few parameters. The first parameter is the lifetime of the link that we want to create in seconds. So here we're creating one that lasts for 5 minutes, 300 seconds. Then we're giving a get parameter because that's the method that we want to use to get the object, obviously. Specify the bucket and the key, and you're given back that URL. Now, by default, it's going to give you back a non-SSL link. So if you are not using CNAMEs and you just want to give out that raw link but prevent a certificate error, you can use that force HTTP equals true flag that you can see in the second example there, and that'll force the URL generation to give you back a non-SSL encrypted URL. So that's a way for avoiding certificate errors. Now, if you do try and request an object for which the signed URL has expired, you'll get this little bit of XML that comes back in the browser. So a little bit of a trick, if you're using this feature, is to have server-side code that checks the validity of the object links and doesn't necessarily display the object link unless it's valid, because you don't really want to have your customers facing this pretty user-friendly error message. So there's mechanisms for achieving that using the server-side code, which customers tend to use. Okay. Another feature that's a cool feature we talked about actually in that Mojang example at the top of the deck, the top of the webinar, is object versioning. So object versioning allows you to preserve object histories. So if you're overwriting an object, this will allow you to preserve prior versions of that object, and it's persistent even after that object is deleted. That history will be held. Now, importantly, you can't have versioning and lifecycle rules active on the same bucket. Once you turn on versioning, you are switching off lifecycle rules for that bucket on a permanent basis. So if you need to use versioning and lifecycle rules within your application, keep the objects in separate buckets that you're going to apply the two different features to. And because of that reason, when you try to turn on versioning, you have to click through this little pop-up which says, are you sure you want to do this? Because it will disable lifecycle rules. Okay. Once you've done that, though, you can suspend versioning temporarily, which means that for the period of the suspension, new versions will not be recorded in the version log. So if you want to have a clean environment where you're going through a large number of version iterations very rapidly, but you don't want those to appear, you can switch off versioning temporarily, but it cannot be permanently disabled once it's been activated. Okay. Okay, more code samples. So here's a code sample looking at versioning. Again, this is using the Python SDK. So we're once again creating a connection object, we're creating a bucket object, and then from that bucket we're calling this list versions method, which will create a list, Python list, containing all of the versions of objects within that bucket. And here we've got a simple bit of code that just prints those. And if you want to access one of those prior versions, you just create a key object, passing in the version ID as a parameter, and then you can get the contents of a prior version. You can see here of different versions that we're retrieving using that API. You can also combine this with those time-limited URLs that I talked about previously. So by passing in a version ID to the generate URL method, you can generate a time-limited signed URL for a specific version of a file. So again, quite a useful feature for certain use cases. Okay, let's move on now and talk about metadata. So in common with most object storage systems, it's possible to store system and, well, it's mandatory to store system-generated metadata with an object, but it's also possible to store user-generated metadata with that object. And this means that you can add supplementary metadata to an object either at the point of creation or later on in its lifetime. These are the system metadata objects that are created at the point at which an object is created within S3. And obviously you can retrieve this data using the API, and you can also see this data via a console actually. So this is how the console is populated with properties information about the object, obviously. And you can store your own key value pairs alongside an object as metadata, and you can have those key value pairs returned with requests for that object. So this enables you to enrich the data that you're storing with an object. And once again, there's a code sample here, a very simple mechanism which shows you how to set and get metadata from an object using the Python API. There's more detail on this in a longer code sample which is available rather in the GitHub repo that accompanies this webinar. So if you want to see more about how you can set, update and retrieve metadata, please have a look at the code samples and grab that. Okay, we're almost done now, so we'll just move on to the final section, which is advanced feature, I guess, in fact, not necessarily part of S3, but another AWS service which can work with S3 to help you. It's called CloudFront. This is a very, very popular service actually amongst organizations that are Hi, it's Ian rejoining here. I'd like to apologise for that. We had some issues with the audio there. I'm not quite sure when the audio dropped out. So I think the last few slides were probably lost. So we'll probably restart from this location where we were talking about metadata. Apologies for the issue with the audio there. So a system allows you to store system and user-generated metadata. Now this data can be used obviously to enrich objects. System data is stored automatically when you place an object into S3. And this is the data that's actually used to populate what you see in the console when you access object properties or look at an object in the console. So that's where this information is used, the system metadata is used. You'll also have the capability to set user-generated metadata for specific objects as well. And that's as simple really as just creating and storing key value pairs along with the objects. You can actually do this via the console, and additionally you can do this using the API or the various SDKs that are available for S3. And this is an example actually of setting and updating metadata using the Python SDK. So you'll see there it's possible to set system metadata. It's actually a longer code sample which shows you how to do this, available on the GitHub repro. So if you're interested in how to set system metadata, then please take a look at the GitHub and you can find the code sample there. It's a very powerful feature, particularly because you can display metadata at the same time as an object. So you can use this for offloading some aspects of metadata storage from applications that use S3 directly into S3 itself, rather than having to do that yourself. Okay. The last thing we're going to cover is to talk quickly about CloudFront. So CloudFront is a mechanism, a service actually, that's integrated with S3. And CloudFront allows you to dramatically accelerate the delivery of content from S3 to global edge locations around the world. So it's a content delivery network. We've got 40 of these edge locations today that are located close to internet exchange points globally. And because they're located close to these internet exchange points with really high bandwidth and low latency connections to the exchange points, users that access content from these edge locations will see a dramatically improved user experience. You know, they'll get much lower latency, and it's also a mechanism for supporting even higher access concurrency to objects. So got many customers that use this for extremely high traffic websites, people that use it for pushing out software that might be, for example, required to update applications or operating systems on mobile devices. That's another good use case, or software distribution use cases in general. Anywhere where you need to distribute large amounts of content around the globe and do that in a really performant manner, then CloudFront's a potential solution for that. The way that it works really is that the first time a user requests a piece of content, if you're using CloudFront, they'll go to the CloudFront edge location, they'll request the content will be pulled down into the CloudFront edge location, and it will be delivered to the user. The next time a customer wants to access that same piece of content, it will be delivered locally, directly from the CloudFront edge location without recourse or returning back to the origin location. So that's how the acceleration is achieved. Importantly, this is not just for static and dynamic website assets. It can also be used for RTMP streaming. So you can have a media file in one of your buckets, and you can serve that directly from the CloudFront edge locations using RTMP. So it's good also for video and audio streaming, not just for static content delivery. Okay, just looking quickly at how you set this up. So the way to set it up is to create a content distribution via the console. So you go into the CloudFront section of the console, and you're selecting either a web or RTMP delivery mechanism. This particular example here shows a web-based content distribution being created. You then be given this form. So in the origin domain name, you would put in the S3 bucket. Okay, and you can set various cache control and forwarding properties here as well. You can also decide which CloudFront edge locations you wish to use for delivery, and there's some different price tiers available depending on how global you go with the delivery distribution that you're going to use. And we'll show you how to leverage this within a piece of HTML content in a second. So that's setting up a static content delivery CDN. You can also set up a dynamic content delivery CDN. So this is one for streaming media, for example. And again, you're presented with a similar properties form that you need to complete, where again you'll choose the origin domain name, which is the S3 bucket, and set some other parameters. At that point, once you click Create Distribution, your distribution is then live. And to access those distributions, once you've created the distributions, you'll be given these CloudFront specific domain prefixes to use. So you would put those domain prefixes into your web page, or set up a CNAME which points to those distribution prefixes if you've configured that appropriately in the prior sections. And then that content would be delivered with acceleration and with a really high and consistent user experience directly from CloudFront without recourse back to the origin servers or recourse back to S3. So super mechanism for getting high scalability and really good user performance. So we're running out of time, so we'll just quickly summarize. S3 allows you to stop doing these activities. So you don't have to capacity plan, you don't have to manage the storage, you don't have to worry about backups or even backups of backups, and you don't have to worry about maintaining or replacing hardware which might fail in your storage infrastructure. All that is taken care of as part of the service. What we tend to find with customers that have the basics down is they're quickly moving on to some advanced use cases for S3. Now that includes things like this. So using S3 with SDKs to incorporate S3 into apps. You can use S3 to bootstrap and drive EC2 instances on startup, and we'll talk more about that in an upcoming Masterclass webinar on the 26th of March, where we're going to be talking about a Masterclass for EC2. So when we do that, we'll actually link back to S3 and show you how to bootstrap instances using scripts and other data materials, objects that are stored within S3. Thirdly, backup and archive is a common use case. We also have customers that are using S3 for advanced use cases with document storage, using versioning and the security model to enable that. Obviously, we've touched there upon a web content and CDN use case, which is very, very popular. And lastly, and again, we'll touch upon this in an upcoming Masterclass too, customers are able to use S3 as a mechanism for storing logs and data that they want to access and analyze using our Elastic MapReduce, our EMR service. So those are what we typically see as some of the advanced use cases that may follow the basic use of S3. And if you want to discuss any of those with us, submit a question and we'll get back to you, and we can provide you with some further references and resources which will help you explore some of these advanced use cases in a little more detail. Okay. So the materials, as I've said several times, are available immediately after this presentation. So please go to the attachments section if you want to access the materials. You can download the slides, and links to the references and also links to the GitHub repro are available there. So please use those. And lastly, just to close, I'd like to just remind you that we've got some Twitter accounts now that we're using to provide local event news and updates to AWS customers and partners across Europe. So if you're interested in finding out more about what we're doing in Europe in the English language, then follow us at AWS_UKI, and you can stay up to date with that on our events, upcoming webinars, and also product announcements and other relevant info. And if you want to get the latest news about AWS globally, including, again, more product announcements and obviously a really good stream of examples and customers that are using the service, please follow us at AWS Cloud. So that concludes today's webinar. I'd just like to ask you to spend a couple of minutes rating the webinar just by clicking the rating buttons in the right-hand corner of the screen. And I'm going to leave the webinar open for a few minutes after the time runs out, just to allow you to submit any questions that you might have, and also to let you follow those social media accounts if you're interested in doing so. So thanks again for joining us today. I'd like to apologize for the issues with the audio during the webinar today, and I hope to see you at our next event, which will be Getting Started and Best Practices on AWS, which takes place on the 19th of February. Thanks very much. Bye-bye.